The minimum horizontal velocity v that must be imparted to the m2 towards right in order to just move m1 over surface. You see this just in order to just move m1. I have few more problems related to this, similar to like this only I'll be discussing. Okay, we'll start with we'll take help of diagrams a little bit, we'll understand. Minimum velocity, it should be imparted. So initially this will be a test. Then what actually happens, we'll see it. I'll project with a velocity u. Then as it starts moving, initially spring is relaxed. Initial spring is relaxed. Here, what are the forces that are acting? The friction F2. Spring will get elongated. Normal contact. Weight M2G. Agreed. So it will undergo retardation, no doubt. So as it starts moving, its velocity will keep on decrease. V will be less than u. The spring will get elongated. The spring which is getting elongated now will try to move the block, no? But if the spring force is less than limiting friction, the block will not shift. So here's some static friction, I'll show it. Now is telling like what should be the minimum velocity so that this is about to shift. Minimum horizontal velocity. Tell me like when I project with a minimum velocity, when this is about to shift, what is the state of this block? Student has to put effort in understanding this situation. I have next one more very good problem for me to do based on this concept only. When minimum comes, then what is the state of block M2 when M1 is about to shift? Anybody wants to answer? This has come to instantaneous rest. Then here is what the spring force. I will take some X KR. Okay, so any simple KY, I'll take it. No problem. When this block M1 will shift, when the spring force is just greater than or equal to this one. So we'll write a condition now. Block M1 will shift when KY greater than or equal to mu M1G. I think this idea. Now for that, the spring should be elongated. For the spring to get elongated, I'm projecting this block. When the block is moving, spring force does negative work, friction force does negative work. And finally, it has come to instantaneous rest. So what is the Y? Y is the elongation. From here, we have to try to make observation of your teacher, how he is taking help of diagrams. Tell me, what is the displacement of block Y? So this end will not move, no? It is there only, you can see it. This end is not getting shifted. This end of the spring is moving. So what is the elongation? Y. Spring force does negative work, friction force does negative work. Okay, how to bring that minimum value of U? So let me apply conservation of work energy theorem. Initial kinetic energy, work done by normal contact, work done by weight. work done by friction, work done by spring equal to final kinetic energy. Initially, I'll project with a velocity mu square. Work done by normal contact 0, work done by weight 0, work done by friction minus F into Y, minus F2 into Y. Work done by spring force K Y square by 2. Directly I'm writing it equal to finally. Now when Ky is just equal to mu m1g, then this will become minimum. Ky equal to mu m1g, then this will become minimum. So mu m2g. Do we know why I'm going to bring from here? When you substitute this y, it will become minimum. I think what you should do now, calculate the y. Don't substitute y here. It will become lengthy calculate. Directly calculate the value of y. Substitute here. You'll get that value of u. This u is now minimum. Sir, how you can say minimum? Because I assume y equal to ky just equal to mu m1g. To have this much of elongation y, so I should project with that minimum speed, no? Sir, if I project with a velocity more than this, then when this is shifting, this will not be a test, this will have some velocity. Please do analyze. When you project with a minimum velocity, when m1 is about to shift, this will be at instant rest. When you project with a velocity more than u minimum, when m1 is about to shift, what is the state of this one? This will have some velocity. Here I had to write about to shift. Okay, so again the best friend, Valkenji theorem. You see that is a really best friend. Make observation. I'll go to the next problem. Answer is root of 2.8 meter. Verify calculation afterwards. Calculations okay, all of you? Can you manage, or I have to show?
We can manage, sir.
You can manage. Yeah, because let me just discuss the idea, sir, so we can